Advanced special cases factoring, not really that advanced, it's just the extension of the special cases. Okay, starting off with a normal special case, and we're going to build all the way up to this crazy thing. 9x squared minus 1. You notice there are two things there, and they're perfect squares. Big sign, big sign. What happens to the middle term of these things? That's a purposefully more difficult question that you will hopefully figure out by the time I get to that. So here we go. I'm going to break these things apart. I have 3x and 3x, because the 9x squared, we square root this basically, we're basically square rooting the thing. To get a 3, an x, and an x. What are the signs? Negative, positive. Keyword there is going to be opposites. They are opposite signs, which we'll get to that here in just a second. And then the 1, you square root the 1 and you get a 1 and a 1. Because 1 times 1 is 1. 1. Okay? Now, what would happen, hypothetically speaking, what would happen if these signs were the same instead of opposite? This would be positive. This would be positive. We talked about that before. The end situation would be positive. So let's just do it right here and see what happens. 3x plus 1 and another 3x plus 1. Okay, this is important because if you understand this, this becomes far easier. Okay, so 3x times 3x is 9x squared. Does that look familiar? Oh my God! And then I do 3x times 1 to get 3x, and another 1 times 3x to get another 3x. What would have happened here if the signs were opposite? It would have been a positive and a negative 3x, and what happens to both of those opposite 3x's?
They combine.
They combine to get what? 1? 3 minus 3. 0. Cancel out, cancel out, cancel out. It's the biggest concept you need to understand of why these look this way, right? Why does this look this way? Let's talk about it here, okay? So, these double 3x's here don't cancel out because they're not opposite. See that's what I'm trying to see, the big picture. If they're opposite, they cancel out, right? I am pointing right now, it might look a little crazy, but right now I am pointing at the middle term. ax squared plus bx plus c. I am pointing right now at the letter b. Do you see it? No, why is it not there? You see it? I see it, Coach B. This is Coach B, but I'm pointing at B. There's no x. Oh my God, why is there no x? Because it canceled out, right? That's the whole idea. So anyway, continuing with this non-cancel out version, because they're both the same, which does not cancel out, and then 1 times 1 is 1. I get that 9x squared, but these give me a plus 6x and a plus 1, which is not this. See what I'm saying? This cancels out if the signs are opposite, is the biggest thing I'm trying to hammer in right now, okay? Another thing that you might notice is if the signs are the same here, a plus and a plus, what is the sign of this multiplying number at the end, right? It's going to be a plus. And if the sign of this number right here, if this is a minus, that tells us, 1, the signs have to be opposite. And therefore, if the signs are opposite, what else happens? They cancel. That's the biggest two things you need to know. I'm trying to show you the clues of what it's trying to tell you. And if you understand that, this becomes very easy, okay? Because you're going to want it to be easy. All right, so now, moving on. We have this, which looks very similar to that, right? They just swapped it. They swapped it, okay? So, it's not that though. I'm going to go into my thing. Factor it, okay? Again, there's no middle term. It looks the exact same. We have perfect squares, a binomial, two things, and perfect squares. Cool. So the 1, just like this one goes here, 1 and 1. The signs, like we've hammered in so much right now, are opposite, because there's no middle term. And we have the r and the r from the r squared. That's your answer. I hope you can kind of see the system here. It's the same stuff every time. It's square rooting, square rooting. Perfect squares, split them up. Perfect squares, split them up. 9, 3 times 3 is 9. Cool, right? Now, there's one step here. There's one step here, and it's the step that people always forget. You technically do it every time. we technically did it both times here, or I at least looked for it. I didn't say it out loud purposely because it would have given away the clue here. What's the first step that you always do, but you might not sometimes have to do, that I should do right now, that you might notice? Greatest common factor. Greatest common factor. I heard that. Greatest common factor. They have a 10 in common, and they have a p in common. That is the thing that everybody always forgets to do. Oh, factoring, okay. And then you forget to, what do they have in common? What do they have in common, right? So, 10 divided by 10 is 1. 3 p's take away 1 is 2 p's. Or you could say pp.
Oh, I get it.
There you go. Okay, cool. Potty humor, okay? We got minus 1,960 divided by 10 is 196. P, take away a p, no p's. Okay? All right, so now, I can now factor it. It's a perfect square and maybe a perfect square. If you don't know your perfect squares, I didn't even know what this was. I kind of had a guess at it, but I will show you a trick in the calculator. You're gonna have 10p, set up your parentheses, put the p's there, because p squared breaks up into p and p. The signs are gonna be opposite. And let's see, oh my God, my phone. I need somebody else's phone calculator. Oh, hey, I'm still yours. Okay, so phone calculator. This is a cute phone though. Not my phone though. The phone is, this is my phone. It's on, okay, anyway. I'm gonna hold it sideways. Oh no, I have to unlock it. Oh God, oh, I can unlock it. I unlocked it. I hacked into her phone. Okay, there we go. I apologize for everyone online that's been watching.
Sometimes it doesn't do it. I don't know why.
Whatever, your phone's broken. You need to go and get a new one. Hey, there we go. Watch that live. A phone that works. Thank you. Okay, so you might not know this in your phone calculator because you probably aren't making calculations on your phone. You're doing other hooligan things. 196. 196. Okay, there's a square root button right there. It's right next to the 1 divided by x. You press that button and it square roots the number. It's 14. Okay, thank you. And not you. Oh, now it works. Great.
You were just doing your own.
Tell that to the people online, the time I just wasted for them. All right. It's a 14. Cool. 14 and 14. Awesome. Cool. Done. And that's the answer. If you haven't noticed also, in general, whenever you learn factoring, we learned factoring with something they all had in common. Then we learned special cases factoring, and then we did the thing where they all have something in common. So it's the same thing as this. Same two problems, they just added a little sprinkle of, oh, what do they have in common? Okay, cool. Now, last problem, I'm gonna go right into the answer and see if it makes sense, okay? And I think the best way to show this one is to just do it, and you'll just be like, okay, I can kind of see that maybe. So, did the middle term cancel out? Here. A, B, C. Did B cancel out? No, it's right there. So, did we have this setup of everything's exactly the same except the opposite signs? Is that going to be the answer? No. This is still going to be a perfect square thing, and maybe you'll see why here in a second. I'm looking at this. What might I put in the front? Ooh. 10x and 10x. Okay, stay with me. I'm looking at the back over here. What might I put at the back? A 9 and a 9. 9 times 9 is 81. 10 times 10 is 100. Okay, cool. Okay. Are the signs going to be opposite? No, because if they were, we'd have some canceling going on. We'd have the cancel thing here. There wouldn't be that. It would look, you know what I'm saying? It'd look different. So this tells us the signs aren't the same, right? The signs aren't opposite. And then this tells us also the signs aren't opposite, because if they were opposite, they would multiply. That 9 and that 9 would multiply to get a negative 81, right? So anyway, I'm trying to make it very clear it's not opposite signs. So that's either going to be plus plus or minus minus. And what do you think, based off of we use this, what do you think the sign's gonna be for both of these 9s that is the same sign? Plus and plus, yes. Okay, so whenever I do this, that's the answer. So you're done there, cool, done, move on. To show you why, 10 times 10 is 100, x times x is x squared, followed by a plus 90x and another plus 90x, which is why you get that 180. And then you have your 9 times 9 is 81 for the full circle, okay? Boom, done. Special cases factoring advanced.